This is the Holley version 4 software. I'm going to explain how I set up the ECU for the Holley HP EFI to control and engage the AC system on my Mazda RX-7. First thing I did was I set up for the ECU to receive input and to trigger an output upon engaging the AC system. This allows the ECU to know when the AC is on, of course knowing when to bump up the idle via the idle air control valve. So the first thing I did was I figured out how the outputs and inputs wires would be set up on the auxiliary harness. If you go to I/O, you'll see that you have the inputs and outputs here that are pinned themselves. This identifies via the pin map, which is here, which output and input that you have created. Of course, you can, once you create these inputs and outputs, you can drag them, drop them to each one of the pin that is associated with a wire on the auxiliary harness. The F, H, 5, and G is going to indicate whether the input or output is a ground, a hot wire, a 5 volt, or pulse width module. Please refer to the Holley HP EFI wiring diagram to see exactly which inputs and outputs can do what. They are limited. Some can do some things, but not all of them. So the wires have to be specific. So with the pin map, these are all reserved these are all color-coded wires on the auxiliary harness. With the pin map created, I go into inputs and outputs. For example, right here we're looking at the inputs. I have AC button on, which is the actual AC switch coming from the car, is looking for a 12 volt input. I have that enabled. The ECU pin here. I also have AC pressure sensor. I have a GM pressure sensor that is wired to the AC system, which ultimately acts as a high pressure and low pressure switch. This 5 volt sensor is mapped. However, if you go into the configure section, we'll see what the high and low is. The custom pressure set to PSI. All your cautions and displays. The important piece really is this down here. As I scroll down, the pressure is mapped per voltage. I found this information on LS1 Tech for the OEM LS1 sensor that Half Spec uses in his AC line kit. This is perfect for understanding that whatever the ECU sees per voltage, it associates a pressure with that. Going back to inputs, I have two others here. The digital speed, which is not yet set up, which would be for traction control. It's not used, it's set up. And then of course traction control retard for logging, also not used. You can see the only two that are enabled. We look at our outputs. Now we have outputs that are directly correlated to wires on the auxiliary harness portion of the ECU. We have some outputs set up. The first one you see, turn on AC compressor. Now this trigger is a ground. If you go to configure, we have some parameters set. Switched input trigger. The output will activate when the AC button is enabled. Again, when the input that I have set up previously receives the input required, then this will trigger this output. Now we have the option to add AND. Now there's sensor input triggers as well. What this means is that before this output will be triggered, there must be the AC button pressed at the top, as well as these parameters met at the bottom. I set up 2. All sensor inputs will activate switch to output when enabled. You have options to go single, where if any one of these singular things were satisfied, it would trigger it. However, The output will activate when the AC pressure sensor is above 20 psi. Of course, the voltage from the pressure sensor needing to see enough voltage to indicate that the system has at least 20 psi in it. This is for protection. If there was a leak in the system that it drained out, it would keep the compressor itself from being activated by the ECU. Now the secondary deactivate is above 350 psi. Again, in range mode. This is for the pressure sensor itself. If there was a blockage in the system and the pressure sensor voltage indicated above 350 psi, then it would essentially turn off this switch trigger would not work, this output. Now the second piece I did was this output will activate when the RPM is above 600 RPM. What this does is allows the ECU or the ECU to not turn on the AC compressor while the engine is starting. As long as it's above 600 RPM, then you have no problem. Furthermore, if you're getting on it above 5,000 RPM, that could possibly overspin the compressor. This is exactly what the OEMs do. They don't turn the compressor on immediately when a vehicle starts, and above certain RPM they turn it off so you don't over rev the compressor. These control the output of the compressor. Now you could do linked outputs, but I chose not to. I did add a delay, start activation delay for 1 second. So when you push the AC button to turn on the compressor, there is a delay of the output being switched by 1 second. We go back to outputs, and we see I have fans set up, I have a TAC set up for the factory pulse width module that is no longer utilized with the Holley gauges. Of course, they read directly from the ECU. And then, of course, start clock as well. That has to do with the tuner, Scott Evans. He set up a start clock, which was an internal thing that's not defined. Those essentially have really nothing to do with the AC system. This right here is what it's looking for the output, turning on the compressor, which is triggering a relay, and then, as I mentioned before, the input, which is the AC button giving the ECU 12 volts using that input, and then of course the pressure sensor, which is a 5-volt sensor that we're using for safety. Now that we know that the ECU can see when you push the button in the interior to turn on the AC system, and then also trigger a relay to activate the compressor, we know that the ECU sees when the AC is engaged. Now the biggest issue with AC is the compressor has a load. So what we had to do is we had to go into the Advanced tab under one-dimensional mapping. We enabled IAC for AC. Now what this does is this is going to give you an IAC position offset. Essentially the IAC is there to control the idle as things fluctuate. The AC compressor adds an additional load upon the engine itself. Thus when the load increased, the IAC must give the engine more air to increase the idle. So what we have here, the x-axis, is TPS, which ultimately identifies with a 0 TPS. You're at 0% TPS, you're at idle. You're not activating, you're not controlling the fuel, you're not throttling it up in any way. So I'll zoom in here so you can see it. You see that it's enabled. This table will activate when the AC button is on, which means, of course, our input that's looking for that AC button being pressed, as soon as that gets 12 volts, as we indicated before in our input tab over here, when it sees that, it will activate the table. Now there's no other secondary activation here. We could set up a secondary activation table. This table will activate when maybe the TPS is below 1%. So that's another thing that you could possibly do. You have to be careful with your secondary activations. So nonetheless, here's the thing about this. no matter what, with this single activation, the AC button on, you're getting an additional 80%. The new owner had spoken about the car idling down with the AC on and the idle hanging. That would tell me that this either needs to be lowered, this 80% increase, or what we could do is add the advanced able, right? You're going to activate switch enable with the AC on and the TPS below a certain percentage, right? So, or you could, trigger it below 1% and turn it a secondary activation above, 1 or 2%. That way that this bump, this AC, would not be, this IAC increase would not be affected above idle, essentially. So with the idling down problem, what you could do a couple things. The IAC is working right. It understands that when it has an additional load, that it needs to apply more air. This is just being preemptive to give it more air initially when that AC compressor is engaged. You could lower this percentage. You could maybe take it down to 40%, 50%, give it an extra bump initially to soften the AC compressor engagement, and then the IAC would do its thing from there. The IAC is always going to give it more air when it indicates that the idle is getting below a certain range because we have it set at a particular RPM. So nonetheless, this is the area right here that you can control this. Again, it's really nothing more than a series of if-then statements. This can activate it and or this can activate it. And then we have to think about how that all works. My recommendation to the new owner would be to lower this percentage right out of the box to where it doesn't affect it. So you can see right here, 0% in the neutral value that does not modify the whole position. A positive value increases the whole position. Now that whole position, that is a metric within the idle portion of your parameters for the ECU itself. So the IAC hold position being at 40%. So IAC hold position is whenever you're on the throttle, when the TPS is above 0%, the IAC automatically goes to this position. With that in mind, it's at 40%. As it says, a positive value increases the whole position. Well, how much does it increase it by? 80%, of course, which adds to 100. So it can change things in certain areas. You just have to be mindful of that. That is an essential rundown of how the ECU is controlling the AC system in this Holley EFI. Version 4 gives you this advanced tab that we have utilized here. This advanced tab gives you all the things, tools that you need to go through and add your own parameters, add your own inputs. The possibilities truly are endless. I hope this has been informative, and I would like to thank you for viewing.